So this is the last section of radian measure, and this part is called coterminal angles. What are they? Angles that are coterminal will have different measurements but the same terminal arm positions. Let's talk about Math 20-1 stuff first. If you don't remember all this, go back and review the stuff in the trig unit. So every time we construct an angle, we need to have an initial arm, and we also need to have what is called the coterminal arm. And then whatever angle that we build from this, we call the angle theta. So initial arm always start at 0 degrees or 3 o'clock. This is the terminal arm. Depending on where the terminal arms ends up, your angle may be wider, may be narrower. If your coterminal arm is just here, then your angle is of course narrower. And if your terminal arm here, terminal arm, then of course your angle would be wider. Alright, so let me do a general example to illustrate this. Alright, so let's do this one here. Alright, in this case, starting from here, that's your 0 degrees, go counterclockwise. Just a review here. If you go counterclockwise, your angle measurement would be positive. Positive this way. If you start here and go clockwise, that would be a negative measurement. Not just that, in math, when we talk about starting from here and do either clockwise or counterclockwise, we call that the standard position. Again, these are all Math 20-1 stuff. Anyway, so let's quickly work out a general example. So if you start from here and then measure that, of course, this gives you 180 degrees. Now, let's do it in two different ways. So this case, let's do a positive rotation and negative rotation. So I will represent the positive rotation in blue. It's just my personal preference. The negative rotation in green. Alright, so if you do a positive rotation, now look at this. Angles that are coterminal will have different measurements but the same terminal arm position. So if you look at this is our endpoint. Now if we go counterclockwise, it's still not hitting our terminal arm. No, 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 no. Now here we go. It hits the terminal arm. So if you look at this gives you 180 degrees. So what is the new angle now? You add 360 on top because we just did a full rotation counterclockwise. So 180 plus 360 gives you 540 degrees. Now the green one, we're going to do a negative rotation. So except this time, the negative means we are doing it counterclockwise. So if we start here, follow this, no, 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 it's still not hitting the original point or starting point. No, 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 and yes. Now look at that. It ends up at the same location. It has the same terminal arm. It's the same spot, you will say, but that gives you a different measurement. This is already 180. But now because we do the rotation counterclockwise, therefore the angle that we just added would be negative. What was the angle we just added? One full rotation, 360. Okay, 180 minus 360 gives you negative 180 degrees. So if you want, you can do the Math 10C stuff, construct an angle with 180 degrees, and then construct another angle with negative 180 degrees. They would all end up at the same spot. Same thing here. Construct an angle with 180 degrees, and then construct an angle with 540 degrees. They would end up at the same spot, i.e. with the same terminal arm. Alright, so let's move on. Draw the angle in standard position and then find one positive and one negative coterminal angle. So that's easy. So that means you rotate. Oh, sorry. Let's go back here and talk about some generalization. So what's my generalization? Whatever angle that was given to you, you either add 360 to that, and you will have a positive coterminal arm. How do I add 360? You go counterclockwise, or you can go clockwise. In that case, that will give you a negative angle. So you minus, okay? And depending on how many coterminal angles you want to get, if you do one rotation, that gives you 360. You can do another one, another 360, another 360, another 360, or you can go counterclockwise. So that gives you negative 360, and then another one gives you another negative 360. If you do another one, that gives you another 360. So therefore, depending on what you're trying to find, if you just want to do one rotation, that would either add or subtract 360. And then if you do another rotation, so that means n would be 2, that would give you another positive or negative 360. Okay, so now let's do this one here. Draw the angle in standard position and then find one positive and one negative coterminal arm. So that's easy. That means you rotate this counterclockwise by 360. This one, I mean just doing it once, just once. This one negative coterminal arm, that means you rotate it that means you rotate it clockwise by 360 just once. Anyway, so I'll just show this to you. Alright, so let's sketch this to make sense of that. So 90, 180, 200 is somewhere here. We don't need a protractor. Okay, so just let you know. So this is 200 degrees. Okay, and then let's do let's use the highlighter. Let's use this one here. So positive means go counterclockwise. Okay, that's positive because you are doing counterclockwise, so that means you add 360. Add 360 to it. So if you look at this, it says 1, so therefore we just do one rotation. If it says 2, you do another 360. Oops, what the heck is going on here? Oh my. Okay, so anyway, now you take 200 and then you add 360 on top of that, so that gives you 560. Because if you do this and then add them all up, that will give you 560 degrees. Now let's do this. Okay, so start here again, but this time because it is negative, so therefore we go clockwise like this. Starting here. Okay, it's not ending at the same spot. Now here we go, it ends at the same spot, and we just had one negative rotation, one. So 200 this time, because we just did clockwise, so therefore in math we say that it has a negative value. So 200 minus 360, that gives you negative 160 degrees. Okay, so the last one here, before we sketch that, there's one thing we definitely need to do, which is to find out what this angle is. Because 5 pi over 12, well, what is that? I hope you still remember that, how to do this from early on today to convert. Well, first, if you see pi in trig, that means this is the angle in radian. And the pi here again means 180 degrees. So to convert this into degrees in angle, you do this 180 degrees over pi, so that we know what this angle is. I mean, if you want, you can use the fact that um, this is pi, this is 2 pi, because 2 pi makes up 2 pi makes up 360 degrees. All right, so pi and pi cancel out. If you do the math, 5 times 180 degrees divided by 12, that gives you 75 degrees. So that's easy. 75 degrees would be somewhere here. The question talks about pi in radian, so therefore we have to do this. So that means this angle is 5 pi over 12. Now we are trying to intimidate you guys with pi angle measurement, but it's the same idea. Instead of saying, oh, clockwise by 360, we say clockwise and add 2 pi. Instead of saying minus 360, because we go counterclockwise, we say minus 2 pi. So if this angle is 5 pi over 12, so that means to find a positive coterminal arm by one rotation, just one. So we start here, go counterclockwise. So that means we just added 2 pi to it. This thing is so stupid. Okay, so that means 5 pi over 12. 5 pi over 12. Okay, and one full rotation counterclockwise, so you add 2 pi to that. If you don't know how to do that, never mind. I'll show this to you how you can do this on your calculator. Alright, so do this. Go to math. Go to this one here. And then we can enter fraction. So for the fraction we want to enter, it is 5 over 12. And then, well, you don't punch in the pi. You're going to confuse yourself. We just want to deal with the fraction calculation because I suck at math. So plus 2 pi. So that gives you 29 over 12. So 29 over 12. 29 pi over 12. You may be confused for the last two questions. I mean, on the previous slide, we multiply the pi in. We multiply whatever we have by 3.14. We are not doing that. Why? Because this pi here represents an angle measurement. And once again, when do you need to know that you should multiply pi in? If we are trying to solve the length of something, or if the question mentions specifically round your answer to the nearest tenth, nearest hundredth, something like that. Okay, so that gives you this new angle rotation, this, starting here, and then ends up here. So that gives you this full rotation, 29 pi over 12 as the angle measurement. If you want to find out what that is in degrees, then you can just times it by 180. But here the question gave us the angle measurement in radians, so leave that as is. Now let's do the last one, last part, 5 pi over 12. So in this case, we start here, same spot, except we're going to do the negative coterminal arm, so we go clockwise like this. This clockwise, that means negative, and now it hits the starting point or the same coterminal arm or the same terminal arm like that. Oops. Oh, this thing is so stupid, you cannot believe. Okay, so now because we just did clockwise, so therefore we minus, except in this case minus 2 pi instead of minus 360 degrees here. So same thing, 5 pi over 12 minus 2. So math, 5 over 12, and then minus 2. Again, we don't enter the pi there to confuse our calculation, and we don't even have to include pi in our actual calculation. So that gives you negative 19 over 12. So negative 19 over 12, oh my, 12 pi, like this. Okay, and again, if you want to convert this into degrees, just replace the pi by 180 degrees. All right, and so let's summarize this. Perhaps before we wrap up this part with the conclusion or some generalization, have a look. So basically, you keep adding 2 pi here for positive coterminal arm, and here you keep subtracting 2 pi. Alright, so if you look at this one here, let's make some generalization. So 5 pi over 12, depending on how many rotation we do. If there's one rotation, we put 2 pi. If there are 2 rotations, we put 4 pi. If there are 3 rotations, we put another 2 pi on top, so that gives you 6 pi. So this number here depends on how many rotation we do. You can write down 2 pi n, or more preferably, or I mean, to me personally, more preferably, there's 2n pi, because it tells you how many rotations is here. If that's only one rotation like this, n would be 1, then 1 times 2 pi gives you 2 pi. Okay, so on and so forth. If there are 2 rotations, then 2 times 2 gives you 4 pi. Okay, and then in this case, we will say that n is any integer, because in order to have a coterminal arm, we have to do 1 full rotation, 2 full rotations, 3 full rotations, so on and so forth. But instead of now instead of having 2 separate formulas that deals with positive rotation and negative rotation, if you think about this, if n is -1, how would that affect this? N is -1, then this whole thing would becomes minus 2 pi. Isn't it the same as this? Alright, so therefore, if you look at that, we can actually combine these two into one general formula, which is this. And also, as I told you guys before, negative is nasty. So what we can do is write down plus, and then n could be any integers. Positive numbers, negative numbers. Okay, so let's say if n is -1, that means we have one negative rotation, or the negative coterminal arm. So -1 would make it negative or minus 2 pi, which is the same as that. So I hope you can see that this can summarize both the positive and the negative terminal arm, coterminal arm. Now to get to the last part, to get any coterminal angle, we can do this. We write down the angle theta and add, just like what we did here, 2n pi, and n could be any integers, positive and negative. So instead of having 2 separate formulas to represent one positive coterminal arm and then one for negative coterminal arm, you can do something like this. Because look at this, same thing, this, except one is positive, one is negative. So by saying that n is any integer, we could put a negative number here. So in this case, this one is for degrees, sorry, it's for radians. Now we can do one for degrees. Again, angle theta, except angle theta in this case would be measured in degrees. Instead of saying 2 pi, we say 360. If you want to put down degrees here, that's absolutely fine. If not, let's just leave that to make it less confusing. Depending on how many rotations you have, if it's one rotation, you put in one n for one. If this is two rotations, you put in 2 for n. If it is a negative rotation for negative coterminal arm, n would be -1, -2, -3, so on and so forth. So n again is any integer.